So we usually start with the survey portion of the program. How many of you have a Raspberry Pi? And it's not still sitting in a drawer? And you've actually built something with it that is not XBMC?
And a lot of hands go down.
All right, who thinks they have the coolest project? All right, what'd you build?
A door lock that reads RFID cards, plays internet radio, and plays random sounds when people come in the door, and posts to IRC who entered the door.
I like it. All right, you're giving the talk now. I'm going to come sit down. Who else?
It tells you if you left the fridge open.
Not my project, but helping a 13-year-old get a wireless doorbell that sends an email when somebody presses it.
Do you guys have a lot of door problems in Australia? What's going on? What you got? Sweet. All right, so for the rest of you who are like, I don't know what to do with my Pi, at least you'll have something to listen to. That guy, I'm not sure why I came. So as he said, we just finished a book, which is a really great way to write a 400-page talk outline. And we haven't seen it yet, so if you have a copy, I'd love to see what it looks like.
We really hope it's good.
We'll start by talking about a little of the history of how this cool thing that now just about all of this room actually owns one of, whether or not you just stuck it in a drawer. Did you have a question? Somebody raised a hand. Sorry, must have been just, it's hot in here. All right, so this guy named Eben Upton was teaching at Cambridge University, and he realized, to be frank, that the students coming in were a bit crap. Because those of, say, our generation or so, we grew up putting together some hardware, and when I was a kid, there was a basic program that took up 4 pages of National Geographic World every month, and you sat there typing it out. And so by the time we got to college, like I wasn't even a computer science major, and yet I could put my computer together. Now they see students coming in who want to be computer science students, but they think that computer expertise is opening Firefox. And so he started working on the Raspberry Pi as a way to get kids seeing hardware before they got to college, to get some programming experience, to have something besides Firefox before they showed up at college and said that they wanted to be programmers. And so in January 2012, they started manufacturing what we call the Model B now. There's also, we talk a lot, basically everything we say is about the Model B. The Model A exists, and I don't know anybody who's ever bought one. So their first run was of 10,000 boards, because he figured that was about all that anybody would ever buy. On the first day, they took 100,000 orders, crashed both of the websites of the stores that were selling them, and there are almost 2 million of them out in the wild now. Who knows what this is?
BBC.
Holy crap, that is the first time I have ever asked that question and somebody knew. And you guys are all like, I know what that is. Including in Scotland, so it's not an American problem. Yes, this is the BBC Micro, which was the inspiration for the Raspberry Pi. It also came in a Model A and a Model B. It came out in December of 1981. The Model B, which was a little snazzier, had a whopping 32K of memory. It was jazzy. This is an ad for the BBC Micro. You can see I put a big red arrow because the type is kind of tiny, but it also was designed for education. This was the whole inspiration behind the Raspberry Pi. And since you guys know what it is, I don't have to keep talking about it. We'll talk about the actual Pi. And there he is. This is the older version, which I just left in here because then we can compare to what the newer version looks like. And I'll jazz through some of this since so many of you seem to be reasonably Pi experienced at this point. When we first started doing talks about the Raspberry Pi, 3 people would be like, I got one, I don't know what to do with it. And so that's where a lot of this came from. But you've got your SD card slot for your hard drive, so to speak, and we'll talk more about choosing those and all the relevant ports. The biggest difference between these older ones and the newer ones, or at least in a useful sense for all the projects we talk about, are those 2 big gold circles for mounting holes. You can actually attach it to something. How ingenious. Do you want to say anything else about the capabilities?
Well, I mean, the difference in the modern version, in case some of you were like early adopters and they jumped out and grabbed one and you're thinking, why would I go and get a different $35 Raspberry Pi that looks and acts basically the same? There's some key hardware differences that were fixed in the later revision, specifically around USB power issues. So if you've tried to plug something into your original Pi and you discovered that it either didn't work or it doesn't work reliably or it works sometimes when the wind blows the right direction, go ahead and get a new one because they fixed a lot of the power issues in the USB.
Yeah, that's actually why our book is called Raspberry Pi Hacks, because when we started writing it, a lot of weird stuff was wrong, and you had to hack around it, and that's not true anymore, and so now it's a weird name. Has lots of cool projects, though. If, however, you are one of those folks who grabbed your Pi back in the beginning, like you said, and tossed it in a drawer, and now you're like, I don't know what I have, it's green, you can just run a quick command, and the output there by the revision number tells you what you have. If it's 2 through 6, it's one of the Model Bs with 256 megs. If it's 7 through 9, it's the mysterious Model A that somebody somewhere surely has. And D through F are the newer Model Bs with 512. So the first thing you need to do is get all your stuff together. And I put this up because what intrigues me is that the entire point of this thing was to get something cheap, because cheap means you can get it into more hands. Because for most of the people in this room, this is not a big deal, this list. Either you are gainfully employed such that you can acquire these things, or for most of you, you probably have 47 of every one of those things lying around your house. But for students, for the educational purposes, I'll talk now because I forgot to put the slides in. There's a group that is doing solar-powered Raspberry Pi labs in places where you can't get electricity. For them, this is a huge deal, these price points. And so when you're talking about using it for educational purposes, because there is a chance you'll do something besides use it for XBMC, you might want to help your community with Raspberry Pis, you have to take this into consideration. That also means you get to go shopping. And this is the crowdsourcing part, because this slide is only useful if you're an American. So does anybody have good Australian sites, since I guess most of you are probably Australian, for buying Raspberry Pi goodies? Say that. Element 14. So you guys mostly like just ship stuff in from the UK? Clearly you already got it under control. Liberate Electronics? Little Bird. Oh yeah, Little Bird is awesome. And dx.com is one of our more recent favorites, and I was on there last night and it was like shipping free to Australia.
RS Components in Osborne Park has them over the counter.
What? I'm moving here. He says he says RS Components has them over the counter, which doesn't exist. So we have a store called Radio Shack that in the 80s sold useful components for people who wanted to build electronics things. Now they sell cell phones. I would like such a place.
In New Zealand, we have Nice Gear, which is just awesome.
Nice Key?
Nice Gear.
Nice Gear. Well named. Yeah. Fabulous. Door guy.
There's also J-Car shops over here.
J-Car.
Not the cheapest compared to buying stuff out of Hong Kong, but they've got a fairly good range. And if you need something to finish off your project today, they've got it.
Because who doesn't want to go shopping? J-Car down the street. They told us there were like 3 of them here because we needed a power adapter.
And a lot of our employers have accounts with them that extras can appear on.
This country's fantastic. I'm moving here.
You're always welcome.
Aw, thanks. Let me get to the end of the talk and then see if you still feel that way. So when you're getting started, the first thing you need to do is get the right SD card. And at this point, for the most part, quality SD cards that have a name on them you recognize and not some weird knockoff logo, probably fine. At one point, there was a significant bug with the class 10 cards, which they claim has been fixed, and yet then we encountered it again. So my advice is usually to go to elinux.org. And if you have ever Googled anything with the term Raspberry Pi in it, you have probably come upon this site. It's a really great resource for all sorts of Raspberry Pi information. And what this page has is a list where people have said, I used this card, it did work. I used this card, it didn't work, and here's what happened. Yeah, so just buy a card with a name that you actually know what it is. Like.
Yeah, and even that list is sort of, you know, how lucky do you feel today, because the vendors are somewhat notorious for changing all of the internal parts and not the part number and not the label or anything on it, so good luck.
And we've actually had really good luck with SD cards. I'm not sure I've actually tried one that didn't work, maybe like once. And they also tell you specifically not to use the micro SD cards with an adapter, but that's what Adafruit sells theirs with, and that's what we have used many of. They work perfectly fine. So display options, that's your party.
All right, so the hardware supports HDMI 1.3, 1.4. It does not do 3D, for all of you who are excited to run 3D through your Raspberry Pi. It does audio and video output. It does not act as an input device. You cannot pump HDMI back through that port. If you wanted to pump HDMI through the GPIO, you'd be crazier than me, but you could probably figure out how to do that. It does have the RCA out, and it's got an analog audio jack as well. So if you don't want to be doing digital, you can do analog video and audio out. It has a DSI connector, and do we have a slide on that later?
I don't think so.
Yeah, so the Pi has a DSI connector, which is a standard industry embedded connector type for things like phones and tablets for connecting a screen into the main board. And you would say, sure, great, I have this old phone, I'll just take the screen off of that and plug it into the Raspberry Pi, and it will do nothing, because the firmware on the Raspberry Pi doesn't know anything about any supported DSI devices. So Eben swears up and down when I see him, and he's running away from me usually, that they are working on some sort of display device for the Raspberry Pi that will be supported through the firmware that you can buy from them, much in the same way that they now have a camera, or cameras to be appropriate, that you can buy from them that are supported through the dedicated camera connector. There is no VGA, so if you're trying to use a VGA monitor with your Pi, you're going to have to convert it through one of the types that's there.
You also have the option, because this is what we do with the Pi, right? We build fun stuff, is to find some fantastic alternative besides just plugging a monitor into it. And so if you happen to be the sort of person who marries a nerdy girl who's working on a book about Raspberry Pi, you have the option that for her birthday present, you can buy a used cell phone accessory off of eBay for a phone that she doesn't have and no longer exists. Because there used to be this phone called the Motorola Atrix, and it was stupidly expensive, and there was this thing called the lapdog. It cost like $400 at the time. And it was a little screen and a keyboard, and basically it turned your phone into a laptop. Now it turns your Raspberry Pi into a laptop. And it's like $40, because who wants them anymore? I'm really afraid that at some point I'm going to have said this enough that there's going to be a run on laptops, and they're going to be $400 again. There's also this guy who has this project called the Kindleberry Pi, where he turned an old Amazon Kindle into a screen for the Raspberry Pi. And even if you don't think that that's a fun idea, it's fun to read his instructions, because they're hilarious. There's an updated version that's more polite, but the original version, his Mach 1, it's like, you should buy a second Kindle, because you're probably going to break the first one. And he essentially tells you you're not smart enough to do this, but he's going to explain why you could if you were smart enough. Tom's plan was to add a touchscreen, which is...
Yeah, so, you know, one of the first things I did was I said, okay, I want to put a touchscreen on this. And so I said, oh, there's the DSI connector. And we talked about how that was all wrong. But, you know, at the time, this wasn't very clearly documented. So I spent a lot of time trying to figure out why these screens weren't turning on and receiving power and being driven at all. But there are some touchscreens that are out there that are USB powered. And so one of the more common ones is one called a MIMO 720. And unfortunately, most of the Raspberry Pi distributions that are out there don't bother to turn on the various code for the display link frame buffers. So for your convenience, these are the module types you need to turn on to enable the display link frame buffers as you go down this road. Now, the display link devices aren't running the graphics chip that's on the Pi. They're running inside of the graphics chip that's embedded inside of the USB device itself. So Linux, or whatever operating system you're running, is seeing that as a second X server as opposed to the native hardware. So you're not going to get the same sort of acceleration or performance that you would get leveraging the hardware that's inside of the GPU. And as a result, things like OpenELEC, which are completely accelerated through the Broadcom graphics processing unit on the Raspberry Pi, are not going to work well at all unless you do some serious kernel hacks. Which you can do, and we wrote how to do it in the book if you really are crazy enough to go down that road, but out of the gate, that's not going to be your best bet.
I also should add, these slides are all online, and I think they're going to be on the LCA site too. So if you're like, oh, I would like to remember that later, you can just grab the slides and not try to grab them now. But if you did want to write your kernel.
Yes.
Yeah.
So
like you just said, you're not going to.
When we first started working on kernel-y stuff with the Raspberry Pi, the stock kernel was 3227 based. Now, the Raspberry Pi code to make the hardware work is not in the upstream, although there is a dedicated team of people working on that task to this day. However, the Raspberry Pi Foundation is good enough to continuously be trying to forward port their changes to more recent kernel trees. Most of the distributions that are out there are running on a 3.6 kernel now, but they have branches for 3.8, 3.9, 3.10, 3.11, and onward. So all of this is in GitHub, so you can go to GitHub and fork the version of the kernel that you're most comfortable with and happy with, depending on the features that you want. At some point, they cut and say we're not adding new features to these old branches, we're only doing maintenance on them, because otherwise this problem scales off into infinity. But if you want to get kernel source for Raspberry Pi, you just clone, and then you can run the make Mr. Proper command.
This is your next chance to be smarter than the Americans that we usually give this talk to. Do you know why there's a make Mr. Proper target in addition to make clean? Oh, I assumed it was the same here. So this guy in the US is called Mr. Clean, and in the UK he's Mr. Proper. What is it here?
Non-existent.
Non-existent? So you guys have no idea why it's called that.
Now
I
you know.
take it back. You're not smarter than the Americans after all. No, you just have different cleaning products. But you have electronics over the counter, so it's okay. Yeah. So now you've got your SD card, you've got a plan, you got to get the right distro. So obviously, we perhaps have a bit of a bias towards Fedora.
Raspbian. No. Sorry.
Fedora, which is the version of Fedora optimized for the Raspberry Pi, of course. But we also generally tell people that you should use the distro that is most well suited to your particular project. And the easiest, most obvious example of that is if you are, I crack on XBMC a lot, I'm sorry. It actually installs really well on the Pi. But if that's what you're doing, if you're installing XBMC, then you should use RasBMC because that's what it's designed for. And it's all in one shot, and you don't have to do anything else. That is not a good reason to use Fedora. Lots of other good reasons to use Fedora. Occidentalis is, I think, sort of misadvertised a bit. It means black raspberry, and that's Adafruit's learning distribution. And that's what they refer to it as a learning distribution. Except then when you start reading the fine print, what they mean is learning if you're already really good at hardware hacking. Or you can find another one. And this is a teeny tiny handful of the many, many distros that people have created for the Pi. And yet periodically, somebody tells me that they want to make a new distro for the Pi because there's not one that suits their needs. And I don't understand how that is even vaguely possible. But we will tell you one slide's worth of information about Fedora. My favorite feature that has made it useful instantly for several projects is the last bit, I think. Here. Oh, no, it's not even on this slide. So Fedora's fun feature is if you're going headless, if you have a totally headless project, you never want to plug in a monitor because you can't get to the port anymore because you encased it in Legos or something. It will, if you put a little headless file on it, it will flash out the IP address through the LEDs and read it through the speakers in a delightful little accent. And I'm sure there are other useful features as well, but they don't blink. There, at one time, well, there still is, there's this bootloader called Berry Boot. And the reason that you might still want to use that is for many, many other distros if you wanted a multi-bootloader for that. But now, there's this distro called Noobs. And if you're starting from scratch, you're not sure what to do, this is an awesome place to start. And now you can buy a lot of SD cards that have been preloaded with Noobs, whereas they were being sold with Raspbian before. So Noob stands for New Out-of-Box Software, and what happens is when you install it on your SD card, this is what you see when you boot it up for the first time. And you pick which distro you want to use, and that's what spins up, and then when you do something really stupid and horrible and you can't even boot the thing anymore, you hold down Shift at boot, and you get this screen again, and you get a do-over. And so that's super useful, especially for kids, if you want to give them a comparison so they can see, well, why is this one different from this one? Or the kid completely borks something up and they need a do-over. They just hold down Shift and you get to try again. Or you're me and you're pretty much a kid anyway and you need a do-over. When you need to install it, regardless of whether you're using Fedora, this is, as far as I'm concerned, the easiest way. You can use DD or whatever you want to do, but there's this handy Fedora ARM installer tool. And you say, here's my image, here's my SD card, do it. And that's the end. Super easy. There are a couple of other ways. If you happen to be using a Mac, there is the SD card builder. If you're using Windows, I don't know why you're here. And then, of course, there's Berry Boot. Or you can just buy the preloaded cards. You can find the Noobs ones easily. I think you can still buy the Raspbian preloaded cards, and then you don't even have to worry about it. Because I think while we were working on the book, I spent more time than anything else re-imaging SD cards. Now's the part where we talk about those power problems.
So your Pi wants 5 volts. Exactly 5 volts. No more, no less. You give it more, it gets angry. You give it less, it gets angry. 5 volts. The closest you can get to 5 volts is good. Now, it's powered off of a micro USB charger. So you may look at your Android phone and say, hey, I've got that. Well, the sad truth is that quite a lot of the Android phones that are on the market today ship you a free charger, and it is worth exactly what you paid for it. And it will not give you clean 5 volts at 1 amp. It gives you something that's close in the range, because for a phone, all you're using that for is to charge the battery, and the battery doesn't care. The battery says, hey, you're low, you're high, it's all good, we'll figure it out. It takes a little bit longer to charge, but you don't care because you've walked off already. Now, for the Pi, when they were designing it, they made the ground level assumption that you were getting a clean 5 volts at 1 amp. And when you don't, things start to go weird. 99% of the problems that people have with the Raspberry Pi are because they don't have clean power coming in. Or they're trying to draw so much power that the poor little brick that's plugged into it can't quite deliver what it's asked for. And there's some, we'll talk about some of the USB issues a little bit later, but your laptop's USB port may not be the one thing you want to use as your power source. Now, there's plenty of cases where this will work just fine, and you'll say, hey, but Tom, it works great for me. What are you talking about? It will be the one time that you're trying to demo a talk with the Raspberry Pi plugged into your USB port that all of a sudden things stop working.
Thank you for not making that happen.
Most laptops have sensible USB ports. And then there's every other laptop that doesn't. And there's not a good list on linux.org as to which laptop has a sensible USB port. So for this purpose, if you want to do a project with your Raspberry Pi, I strongly recommend that you get a good quality power brick for your Pi. There's lots of them out there. And the bonus is that if you get a good quality power brick with a micro USB charger, you can use it to charge your phone and it will charge faster.
Last thing we like to tell you about power is that little silver cylinder is not the place that you put your thumb when you plug in the power cord. And you laugh, but that's what a lot of people seem to think, because there are many, many people whose first time out of the box with their Pi, they stuck their thumb there, they plugged it in, they broke that capacitor off. And it doesn't render your Pi unusable, but if you do decide that you would like to replace your broken off capacitor, that is what you are looking for, and the black stripe goes to the outside.
We may speak from experience.
What's the sound it makes when it breaks off?
Sometimes we have good sound effects. That's not one. I'll work on it for you. The Pi also does not come with an on-off switch, and sometimes you would like to not just keep hot unplugging your Pi. And so there are these handy little points right there, and what you can do is, there we go. And then you get to short it out and make an on-off switch. That's kind of a fun way to have an on-off switch. You just need to add a couple little pins. It's, I think those are labeled P6, what it looks like. But yeah, it's right behind the capacitor that is not your thumb holder. There are a couple of polyfuses on the board, not as many as there used to be, but I show you this because if you are as blind as I am, those points marked TP1 and TP2 might as well be not marked at all. But they do exist both on the front side of the board and on the back side of the board for the assorted polyfuses.
Useful because when you are in a situation where you're like, why is nothing working properly on my Pi, and you didn't listen to me tell you about the good power, you can put your meter on test point 1 and test point 2, and you can say, oh, that's why we're not getting 5 volts across.
Yeah. Or in the case of the one on the back, because I melted it, and sorry, you should go get a new Pi. It is self-healing to an extent, not forever. The Pi has, I've cased up my Pi here, but I'm sure you're all aware, it has 5 handy LEDs that aren't just there to be blinking things on your cool project. They do tell you useful things. And the older Pis have a different legend of useful things that your lights are telling you, which you can also find on eLinux. But that is the basic list of what's going on. The Pi needs to find a set of 4 files on the SD card, and this will tell you what has gone wrong.
All right, GPIO stands for General Purpose Input Output. These are reasonably standard things in embedded computing, where these are pins where you can attach peripherals to in order to hook things onto the Pi in a reasonably standard way. These are just pins. Some of them are smart pins, like PWM for pulse width modulation. You've got a dedicated set of pins for serial console. Some of the distributions will turn that console on by default, some of them won't. But those pins are acting as a serial console. So you can get a 2-wire console cable. They're very common, easy to get a hold of, plug it in there, and all of a sudden you've got a dedicated serial console for your Raspberry Pi. But all of these pins, including the power pins, but I strongly recommend you not do it with the power pins, can be rewired inside the operating system environment so that you can choose what they do. And you can assign them as input or output or both or all sorts of fun things.
The man with the signs tells me we ought to talk way faster. Okay. So you guys know stuff, so we're going to talk about cool projects like that. Camera, teeny tiny camera, so I'm not going to talk about it a lot because we're going to show it to you in some projects. Cases. You should find some sort of case. This I have encased because this is the best case we have. And I finally looked it up. It's from a company called Syntech, C-Y-N-T-E-C-H. The ModMyPi site sells these, and it actually screws together. You can still see the LEDs. Fantastic little case. The other best ones we've had, we 3D printed. Or somebody told me one time, he's like, this is my case. And he had the cardboard box that came in, and he had X-Acto knifed out all the ports around the box. This is my other favorite way to build a case. And this is also usually the part where I explain to you in exorbitant amounts of detail how you need to go about building a Lego case. But
since we don't have another 2 hours, we're going to skip that part.
The man with the time sign, I must have talked too long in the beginning. There is also this set that you can just buy, a Lego brick case. I have an extensive, like I could write you a dissertation on price per brick that you should be aiming for, and this is a poor price per brick set. However, it is cute, and it has a little raspberry on top. So let's talk about cool things. One of the first things that we decided we should do is to gut an old Game Boy case and shove a Raspberry Pi in it. This is the photo of lessons. This is one of the first things that we did with the Raspberry Pi. And so we bought this little TFT screen from Adafruit. It had no sorts of instructions or diagrams or anything. It was just a little screen with some wires. And we didn't have any jumpers or we had nothing else. And so I had tiny alligator clips. And so I teeny tiny alligator clipped the wires into the GPIO. This is the worst idea ever. I found out later that's a 12-volt board, the 12-volt screen. And the fact that this even worked is stunning. We haven't crammed it into the Game Boy yet, which is why I don't have a picture of that, mostly because of that giant RCA jack that it takes to get that particular screen in there. But it will happen one day. Somebody else saw a tiny screen and said, I got a Halloween costume. I am building a Pip-Boy. If you're not a game player, this is from Fallout. And it's a Geiger counter and all sorts of information. And that is what it would look like on your arm until you spill something on it right before the Halloween party. And I think it didn't even make it through the night, but he has you can go to the site, and he has this whole build instructions about how he built the case around it and all. This is Tom's plan. He just wanted to play the games.
Yeah, pretty much. I just wanted to play the games from my childhood, and so the good news is there's lots of other people that wanted to do that as well, and went ahead and ported all the known emulators in the universe to be optimized for the ARMv6 chip and the Raspberry Pi specifically, and then hooked them all into the GPU so that you get fast rendering and real-time performance. In some cases, you can actually get near HD performance out of some of these old games that were never intended to go on an HD TV. So pretty much every game system up through the PlayStation 2 will emulate on a Raspberry Pi in near real time, which is very impressive.
If, however, you would like to educate children with the educational device instead of playing 20-year-old games on it, most of the distros come with this cool little program called Scratch. Do you guys know what Scratch is? Yeah? Oh, I saw a lot of news. So Scratch teaches kids the basics of programming with that. So it puts the code in these little puzzle pieces, and you fit the puzzle pieces together, and then your code works. And the cat walks across the screen. He spins in circles a lot and does this sort of thing. So this is from a book called Super Scratch Programming Adventure that's now in its 2nd edition. And it's great for kids, because what happens is on the left you have a comic book page, and on the right you have instructions in Scratch that help you solve the problems that the cat is having in the comic. And at the end you have a game you can play. So it's just like those basic programs we were tapping out of a magazine when we were kids. You go through it, and you have something rewarding in the end. There's also this cool project that came out of Google Labs called Google Coder. And it runs off the Pi, and you access it in Chrome. And this is what you see when you boot it up. You have the option, the plus is to create your own little app, or there's Gadgetoid, which is sort of like an asteroids game, Eyeballs That Track, or Hello Coder. And when you click one of those, you have the option to see either this is sort of an entry level into the asteroids game. It lets you edit just some of the variables so that you can actually have an impact on it. Or you can just straight out have a blank page and start writing things on your own. And so it's intended to use the Pi to teach HTML, CSS, JavaScript, and Node.js. Oh, I do have this. So this is a picture of the solar-powered lab in Tanzania. My fun pet project is how many of you ran SETI at home in the 90s? Yay! So you were searching for aliens with your screensaver. Well, now you can do it with your Raspberry Pi, yeah. And there's a new system. It's not a screensaver anymore. And there are a ton of other projects. So you don't have to just be looking for the aliens. There's a lot of scientific research that's running off of the new system called Boink. And so if your Pi is just sitting in a drawer, at least install something on it and let it do something while it's sitting in there. This is a joke about Pi farms. This is a guy who looked at the Raspberry Pi and saw a functioning Stargate. And so he's looking for contributors to his project specifically to help with the Pi part. So if you find that interesting, he's done a really nice job building the chevrons and all.
He's also looking for some weapons grade Nacrita. If you have any of that, he'd greatly appreciate it.
I just found this guy's project yesterday and had to stick it in. And I'll just skip ahead. I think this video is going to play. This is his flux capacitor and time. Yeah, that was his Halloween costume. Super fun. There's a project called Pi FM that lets you essentially turn your Pi into an FM radio. OK, I'm talking a lot. You talk. Make words.
So basically, FM is frequency modulation, and the clock chip on the Raspberry Pi can modulate the frequency. So you actually use the Pi itself to modulate the frequency of the clock, and you use one of the GPIO pins as an antenna. If it is legal in your jurisdiction. And you can pipe it a sound file, and it will broadcast it across a FM range that you can actually tune with a normal radio. So you can make it into a nifty little FM transmitter, which goes well with one of the other projects we're going to talk about with lights.
Yeah, well, actually, I don't think that's in here. So we have another project in the book where you turn the Pi into a controller for your Christmas lights, and so you attach it to a relay board, and those come up to about 12 inputs. You add that to this, people driving by can hear the music to go with your Christmas lights. Super fun. This is how we got into this whole Pi land, was some guy put on a penguin suit and let people take pictures with him. We set up a photo booth. Like, you know, you go to festivals and they have all the silly glasses and stuff you can put on and get your picture taken. So the way this works is all you have to do is hit enter on the keyboard, and the Pi takes the picture and as a watermark uploads the photo. We used it in a Fedora booth, and so that's what this was for. This is what you see on the screen. And so you can scan the QR code and get your picture with the penguin, and presumably some information about Fedora. That tiny screen that we attempted to turn into a Game Boy, I decided needed a new purpose. So this is my other nerddom, is making costumes. And so this is one that I did, I guess, about 2 years ago. It's for Mass Effect. It's Ashley's armor for Mass Effect. And the other guy is Captain Shepard. That's the actual Captain Shepard. And no, like for real, like that's the guy with the voice. So I thought, well, I might need some battle damage. And so my idea was I carve out the back of the armor, which is made out of foam, put the camera projecting from the front, and then I put the screen into the foam. And so this is the camera showing you I have been shot through. And if anybody wants to talk costume nerdery, we started talking about plans 2 yesterday, so we should chat about that at tea. There is the XBMC option. The reason that I mention it, because it does work so super well, and it is the best evidence of how this is educational. This is entry level. It is useful for absolutely anybody who isn't even a developer. And I grabbed this out of the comments on the RasBMC page. This guy basically says, I don't know what I'm doing, but it took me like 5 minutes, and now I got a media center. It's fantastic. And so he was my example until I was in a crunch trying to get some instructions written about this. And I gave it to my then 7-year-old, and I'm like, here, go do this. And she installed XBMC on the Raspberry Pi for me. So it's easy enough, my 7-year-old can do it. You got it.
I got this slide. No.
Yeah, that's basically it. There's always like 1 out of 10 people think this is a really good idea. This is a really bad idea. If you think this is a really good idea, you can go to the Rasdroid wiki where they have an image you can download, and you can see how slowly it runs, and then that was a stupid idea, and then you never have to do it again. This is a piece called the a la mode, and it sits on top of your GPIO and lets you add Arduino shields to your Pi. And that is super useful because Arduino has this massive community with lots of well-known and well-documented and well-instruction-written shields for all sorts of things. And this lets you add them onto your Pi. And that's what it looks like when you slap a shield on top of the a la mode on top of your Raspberry Pi. You no longer have a tiny project, but you got a shield on your Pi. Oh, hey, we do have the Christmas lights. I should read my own slides once in a while. That's the Christmas light controller that you should add to your Pi FM in your legal jurisdiction. This, if you can't get away with just giving your wife an ancient Motorola Atrix laptop, this guy, for Valentine's Day, built his girlfriend a bilingual, it speaks Japanese and English, it takes commands, it moves, it projects video because it's R2, so it kind of has to. I'm not sure there's anything that it actually doesn't do, and now she's his wife, so clearly it works. If you are smarter than me and not trying to cram an RCA jack into a Game Boy, you can indeed make an ETPT PC arcade machine, and the instructions for that are at spritesmods.com, and this is what they look like. This is a super fun project, and I can't wait to see it launch. It hasn't actually gone out yet, but the mission is to make an autonomous surface unmanned vehicle for research. They're going to send it across the Atlantic. And that's their waterproof housing, which I call Tupperware. Tom's version of waterproofing is different. I don't even, I don't know if they could get it here.
So there is a very hydrophobic paint that you may have seen on the internet. It is branded Never Wet in the United States. And so one of the things on their website they tell you is to not apply to electronics. I applied it to electronics.
It hasn't been out yet, but I'm sure if it's not here yet, it will be. We have the internet.
It is viable.
It is? Sweet.
I'd have to look it up, but it is viable.
Presumably, it's by Rust-Oleum, so presumably wherever you would acquire Rust-Oleum paint.
Bunnings is going to have it evenings. Given the number of votes we made here in Fremantle, someone will have it.
Yeah. And so it's a two-part process, and it ends up chalky white, and there's a horrible YouTube video of him dropping the pie in it, and it still functions for an amount of time we have not yet determined. And I'm out of time, so I'll just zip through the last couple. This is, I call it the Pizza Hut table, because that's where we used to see them. It's the video game table. They built it with IKEA parts. I had a friend who was looking for a Geiger counter, and he joked, hey, could you build me one with a Raspberry Pi? And I was like, no, wait. Oh, yeah, we could do that. And this is my picture of outer space, and there's no waiting list. You can go build it right now. So there's a friend of ours who lives near us who uses the Raspberry Pis as the central piece of the payloads for their near-Earth orbit photography projects. And they've done quite a few launches now, and this is one of the best pictures. And there's usually a Lego minifig or something hanging out in there. But it's super cool projects, and all the instructions are in the book. But again, so a lot of the book has instructions that say this is a bad idea, but this is how you would do it. So like PyFM, perhaps not legal in your jurisdiction, spraying paint on your electronics, and launching things into space, all encompassed in not necessarily the best idea, but you should do it anyway.
Is that a rocket or a balloon?
It's a balloon. So it's on a weather balloon, and in the US there are these complicated laws that you have to keep the payload under 4 pounds, which makes the Pi perfect. So it's a balloon. And the first time, so he told me about this, and he's like, hey, I've got this great Pi project, why don't you come see the launch? It was about a week later, and I went out to the launch. And they had an argument about how to tie down the balloon, and the wrong guy won, and they lost $200 worth of helium with no payload. These are just a few of the other ideas in the book, and this is more useful because it's resources. Places to learn things, places to buy things, places to find us. And that's about it. Do we have questions?
One in the corner.
Yeah.
Are you familiar with the hack that's come out of the extremely professional brain hack that's come out of Yazaurus with the Raspberry Pi, using that as a brain off an Android-controlled drone?
I did see something about that.
Repeat.
What's it called?
Cepheus.
Cepheus, a Raspberry Pi controlled drone. Yeah, that's another cool. So the thing I called the Pizza Hut table, that gaming table, that is my example of how A, there are so many Raspberry Pi projects that you can never possibly see them all, and B, every cool idea I think of somebody's already made.
We all like a Callaway, because one project you should say no one should ever attempt would it be?
Android. No, I firmly, I was like, I am going to do it. I've spent like a week of my life trying to get that thing to compile. It was a dumb idea. Don't do that. No, there's nothing you shouldn't do, because that's what the Pi is. The Pi is designed to teach you something that you didn't know how to do before. And there is nothing short of injuring yourself, which sometimes is okay, but just don't do anything that's going to kill you. And it's really hard to electrocute yourself in a deadly fashion with the Pi, so nothing.
Yeah. When you start acquiring nuclear materials to make your project work, that might be when you need to slow down just a little bit.
And if you think that the Stargate is actually going to function, then you've gone too far.
You're completely right about not using micro SD card adapters. The Pi I used in my demo on Tuesday only works because I have paper stuffed in the case to pin.
There are some terrible cases that Adafruit sells that when you take out the SD card, it breaks off the plastic that holds the SD card into the Pi.
You flip past very, very briefly at the end about Lego robots. What's the state of the art, the level of maturity of the interface between Lego stuff and...
So there's a very long chapter in the book that I wrote about that, but there's a couple different ways you can interface with the Mindstorms, and I don't have the current gen Mindstorm, so I don't know exactly, because they came out right as I was finishing writing the book, and I told the editor we should hold it for that, and he wasn't interested. So, but the most common ways is there's bindings for almost everything. I'm a Python guy, so I went ahead and did the Python bindings and hooked that in, and that worked very well. I also did ROS, which is not quite as easy, but is a lot more friendly if you're deep into the robotics stuff and you really want to have a wider platform for things. That's a little more complicated because ROS is a large number of components that has to be compiled for the native architecture. On Raspbian, there was an effort that got about halfway there, and then for whatever reason, I think they went to lunch and didn't come back. So I finished up a lot of that for them, and then so the chapter basically on ROS starts talking about how you install the packages from Raspbian, and then how you start building things from hand and patching the bugs around it. So I ended up having to make a GitHub repository of all the forks to ROS to get it working, but it's all in there and you can make it go.
But that's going from Raspberry Pi driving the Mindstorm script, not going straight to...
That's correct. Yeah, no, the Raspberry Pi, because it doesn't have a real-time clock at all, makes it difficult to do direct robotics. Most of the people that are doing direct robotics through them are building a shield that has an RTC on it, and also usually has various stepper motor controllers built into that board. So if you're interested in doing that, I strongly recommend you just go ahead and pick out one of those shields that's out there, and shield's not the right word, but you know what I mean.
So I feel like I've said the word book more than I usually do. I think I'm just excited that it's over. But if you do want it, if you go to O'Reilly, that code gets you 40% off or 50% off the ebook, which is super handy. And I have teeny tiny flyers if you don't write that down. More questions? Out of time?
I used a Pi for streaming local fire radio over the net, and had to recompile a lot of the codec stuff to get it to perform properly using hardflow. How well optimized is Fedora in terms of reconcile to support hardflow?
Everything in Fedora is now hardflow optimized. So some of the earlier Fedora builds weren't, but Fedora is now completely hardflow.
And most of the major distros, I think.
I think pretty much everybody is at this point.
Any other questions? Yes, door guy.
I was just going to mention that with the XBMC distros, there's also OpenELEC, which is smaller and has a few more useful add-ons.
Yeah, he was just saying OpenELEC is small and has useful add-ons. It's one of the more fun and lesser well-known distros.
I like it quite a bit. It gets a good mention in the book.
I came to that one first because I was using that one on my PC already.
Cool. Any others? If you think of something else, we'll be standing around morning tea or whatever.
Thank you.
Thanks.